Hey everyone, wanted to create a t-test video to help you with your assignments this week. The idea of a t-test that you're reading about in your chapters is that you want to compare the means of two conditions. Typically, you're going to be comparing two groups on some dependent variable, and you want to know whether or not the mean for group 1 is significantly different than the mean from group 2. So let me show you in Excel how this works with a specific example. Imagine that we want to calculate words typed per minute under two conditions. Each of these values here is the number of words typed per minute. And you can either have in t-tests a within subjects design or a between subjects design. In a within subjects design, the same participant completes the test twice. Imagine, for example, that we want to know whether or not a typing class is effective in increasing typing speed. So what we do is we ask these participants to complete a typing test prior to taking the typing class. So each one of these values is the number of words they typed prior to completing the typing class. After the typing class is over, in what we would call a post-test, they complete the typing test again. And so for each row here, this is the same participant who's completed the typing test before the typing class or after the typing class. And that's a within subjects design. In other cases, you're interested in comparing two groups on the same test. So for example, imagine that we're interested in whether or not drinking coffee has an impact on typing speed. So we ask one group of participants to drink coffee and then complete the test, and we compare that to a control condition where students do not drink coffee prior to taking the test. So here we don't have the same participant at time 1 and time 2. Here we have two different participants taking the same test under two different conditions. And that's what we call a between subjects design. I went ahead and calculated the means and standard deviations ahead of time. You're familiar with that process. The mean for the condition A is 22.42. It's about 22.5 words per minute. The mean for condition B is about 30 words per minute. And what we want to know with the t-test is whether or not there is a significant difference in these means. Now you'll notice in Excel that there really isn't an area at default about to help you calculate your t-tests, but you can actually pull those, you can pull in an add-on that will allow you to calculate your t-tests. Now I'm using Excel 2013, but the process should be the same for you if you have an earlier version, or I suppose a later version. I'm not sure if a later version's out yet, but basically the idea here is that you go under File and you go to Options. Then you go to the Add-ins area and you want to find Manage Excel Add-ins and then press Go. The add-ins that we're looking for to help us with the t-test are the two analysis tool packs. So if you go ahead and select those and then press OK, under the Data tab, you're going to see a new button called Data Analysis. And this is where you'll access the t-test. You'll see a variety of statistical tools here, including ANOVA and correlation that we'll get to later, but we're concerned with the t-test. There's three versions of the t-test here. The t-test paired to sample for means is the within version of the t-test. And then the between version is either with equal variance or unequal variance assumed. The textbook covers the importance of equal variance in t-tests. I'm not really going to get into that here, but for the purpose of this video, we're just going to use assuming equal variances. So the first thing that we're going to do is calculate a t-test for within subjects. So this is before and after the typing class. So what you do here is you go under Data Analysis, and you select paired to sample for means. Press OK. It will ask you for the two ranges, the two conditions. So you select the pre-test range, and then you select the post-test range. Hypothesized mean difference refers to whether or not you think there is ahead of time you think that there is a difference. That relates to the one-tail versus two-tail version of a test. When you don't know ahead of time what to expect, you always go with the two-tail version of a test, so we leave this blank. Alpha is the region of rejection. This is letting us know the probability at which we will reject the null hypothesis, that there is no difference in means. And I'll get to that when we get to the output. It will also ask you for where you would like the output to show up. And I usually select output range and then just select an area on the page for the output. So you're ready to run your t-test. You press OK. Now this is going to be a bit scrunched, so you'll want to expand it a little bit so you can read what the labels are. Really expand it. So here we can see the mean, 22.42 and 30.14. The number of observations per condition, so we had 7 students complete the pretest, and then those same 7 complete the post-test. The t-statistic is listed here. It's negative 4.43, and we're looking for the two-tailed probability. Remember, we didn't anticipate ahead of time which difference, if there would be a significant difference one way or another. But what we see here is that the p-value is 0.004. That's lower than 0.05. So in that case, we would reject the null hypothesis. Let me show you how this is written up in Word, just to make it a little more concrete for you. Let's say we have our within subjects typing class, and we could type it up this way. Prior to completing the typing course, students averaged a typing speed of 22.42 words per minute, and there's their standard deviation. After completing the typing course, students averaged a typing speed of 30.14, and there's a standard deviation. So basically, the typing class increased the average typing speed of about 8 words per minute. Now, the t-test indicates that this is a statistically significant difference. We have the T. The 6 here refers to the degrees of freedom. DF stands for degrees of freedom. There's the actual T value of negative 4.43 that we got from this cell. And the P value in this case is 0.004, which is taken from this cell. And again, when the p-value is less than your alpha level of 0.05, that's when you reject the t-test. I'll show you again about rejecting t-tests or not with the between subjects example. All right, so the next t-test is the between subjects sample, or the between subjects design, where we're comparing students who didn't drink coffee versus students who did drink coffee. So we want to run the t-test again, but in this case, we're going to use t-test assuming equal variance. Now the process is the same. You select the input ranges. These are the folks who didn't drink coffee. These are the folks who did drink coffee. The means and standard deviations are going to be the same, of course. What's different is how the t-test is calculated. Everything else is the same, 0.05. No hypothesized mean difference, so we're looking at the two-tail test. It asks for an output range, so we'll just drop it right over there. And then, actually, did that work? And then we press OK. I made a mistake somewhere. All right, let's try again. and then the output range. Okay, so sometimes you'll get errors and you just have to repeat the process. Now this is called the two-sample or between subjects design. We're assuming equal variance. What you'll notice is that, of course, the mean and standard deviation, or the means and standard deviations are the same. The data themselves didn't change. What changes is the calculation of the t-statistic. Here, the degrees of freedom have changed from 6 to 12. We have two separate groups, so we have more degrees of freedom. On the other hand, what you'll also notice is that the t-statistic has changed. In the within subjects, it was negative 4.43. However, under the between subjects, the t has dropped to negative 1.84. If we go with the two-tailed test, you'll also notice that our p-value is now 0.09. That's greater than 0.05. So in that case, we can't actually reject the null hypothesis. On the other hand, if you did go with the one-tailed test, you'd see that it is below 0.05 and you could reject it. So that's the important thing you have to remember about one-tail and two-tail tests, is you have to stipulate ahead of time whether or not you're going with a one-tail or a two-tail test. You can't notice that it's not significant under two-tail and say, oh, well, I'm going to go with the one-tail test. That's an ethical violation. You have to select a test ahead of time. So since we went with the two-tailed test at 0.09, this would indicate that there is not a significant difference in drinking coffee versus not drinking coffee. And I'll show you how that would be written up in standard Word. So basically the mean and standard deviation is the same. Students who did not drink a cup of coffee versus students who did drink a cup of coffee, those means and standard deviations are the same. However, when we input the new information, the degrees of freedom changes, the t-value changes, and the p-value changes. And in this case, since we went with a two-tailed test, p equals 0.09, that's greater than 0.05, so we can't reject the null hypothesis. The interpretation here is that there is no difference in typing speed as a function of coffee. If you had gone with the one-tailed test and you had a p of 0.045, which is less than 0.05, you could say that there is a significant difference. So again, that's the importance of articulating one and two-tailed tests ahead of time. That's all that I have for you at this point on how to calculate t-tests in Excel and the difference between a within and a between subjects design. If you have any questions about this video, please let me know.